So from 5.5, go back and look at a few examples with definite and indefinite integrals using substitution rule. I think we should start with that and then we go back. Okay, so this is page 413. Let's look at problem 18, which is the integral from sine the square root of x over the square root of x dx. And then we'll pick other examples. So I'm looking at this function, and I see sine of the square root of x and the square root of x in the denominator. I'm not bothered by this, but I am bothered by the fact that in sine there is another function. So it's a function composition. Sine is the outer function and the square root is the inner function. So I think and I hope that I can say let your y or u or t, whatever variable you want to use, it doesn't matter. If I'm going to use y, or let y be the square root of x, is dy in the problem. So remember, we need dy. Dy is the differential of y. So here we have the differential of x. What does this mean one more time? So this is the base of any subinterval, right? The width times f of x. This is the f of x, the height, and this is dx, which is the width of each subinterval. Okay? So obviously I have to, once I change the variable from x into y, then I have to have dy, because I have to put it in the integral. So if dy is somewhat in the integral, plus or minus a number or a sign, it's fine. But if I have to make up a function, I won't be able to. So when I differentiate dy, when I differentiate y and get dy, what do I have? Not enough? Yeah. Perfect. So y prime is one thing, dy is something else. So let me refresh your memory. Dy is f prime of x dx. Please remember this. And y prime is just y prime. Or if you want, is dy over dx. Okay, so perfect. So I do see dx over the square root of x, but I don't see the 2, which is no problem. I multiply the denominator by 2, and I multiply the numerator by 2. Multiplying the numerator by 2 and the denominator by 2 does not change anything, correct? So then, can anyone dictate the new integral? 2 in front, and the integral from? Sine y. That's it. This, which I hope you agree, this is more human than what we had before. What function, well, which function prime is sine y? Yes, but negative. Yes, negative 2 cosine y plus a constant c, because this is an indefinite integral. But like any indefinite integral, when we use a substitution rule, we have to go back and replace it. So we cannot start with an integral in x and end up with an answer in y. So I have negative 2 cosine the square root of x plus c as the final answer. Can I check? Easily. By differentiating both sides. I should say the left-hand side this and the right-hand side, and I would get the same thing. Let's look at another example. Is this okay? Is this okay? Okay, so let's look at 44. The integral, if we did 44, please stop me. I don't remember. I think we did, but if we did, yes? I think we did. Okay, so let's not do it again. What about 43? The integral from dx over the square root of 1 minus x squared multiplied by sine inverse x. want to forget, or let me start this. I did give this. Yes. Okay, so I look at sine inverse because it's a kind of a special function, right? And I look at the square root of 1 minus x squared. And do I see anything? Can I say, oh, yeah, if I denote this by y or by u, whatever you want to use, then du will be in the problem, or dy will be in the problem. I would not really have a problem with the integral from sine inverse and something else. But I do really have a problem with 1 over sine inverse, because this is a function composition. Sine inverse is inside 1 over x. So that's a different story, somewhat. So when you look at these two quantities, can you say, I think we should let u or y or z, whatever you want, be exactly. Thank you. Nice. But again, it's guaranteed or warranted, if you want, if du is in the problem. Because if du is not in the problem, I won't be able to make up functions. I can make up numbers and signs easily without a blink. I can multiply top and bottom by 2. That's not going to do anything. It's still 1. But is du in the problem? Exactly. And dx. du is 1 over the square root of 1 minus x squared dx. Very good, indeed. So then, the integral becomes, and once I move from x, I have to move completely from x. What is this going to be replaced by? Very good. Du or dy, doesn't matter. Over? I used u, so I'll have to stick with 1. So it's du over u. Okay. Now I have to think. Which function prime is 1 over u? Which function prime is 1 over x? Which function prime is 1 over t? Tom, I found a pen last time. I don't know if it's yours.
That is mine, actually.
You're welcome. Which function we differentiate to get 1 over x?
ln x.
Perfect. So now the answer is, careful.
Ln u.
Yes. Yes, but I want to talk about this, but not before we finish it up. So this is natural log applied to, I should put it in brackets first, sine inverse x. We don't need both, so I'm going to delete the parentheses. Brackets are good enough. So what I'm saying to you, and I have to show it to you, why? Because I have not shown this. I'm saying to you that the integral, the indefinite integral from 1 over x dx, it's not just natural log, but it's natural log of the absolute value of x plus c. And now I need to show you why. In other words, how will I check this? How will I check that the integral from 1 over x dx equals natural log of the absolute value of x plus a constant c? How do I check any indefinite integral? Fundamental theorem of calculus, part 1, which shows that differentiation and integration are inverse operations. So how will I show that this is correct? Differentiating the left-hand side and differentiating the right-hand side and proving that I get the same thing. Correct?
Yeah.
Okay. So when I differentiate the left-hand side, what do I get? This symbol, cancel this symbol, that will always go away together with this symbol. So what is the left-hand side then? 1 over x. But now I'm going to come back to this. So let's start with the absolute value of x. By definition, the absolute value of x has two options. What are the options for the absolute value of x?
X or negative X.
Very good, awesome. In two different situations, when this is positive and when it's not positive. But now I want to think in terms of natural log the absolute value of x. Just slightly different. Is the natural log of x or natural log of negative x? And now I have to be careful, because there is one thing that I cannot plug in natural log,
And negative.
which is? Yeah, there is nothing negative here,
Less than 0.
because when x is less than 0, negative x is positive, and this is positive. So there is something else I cannot plug in natural log. These will always be positive. What I can never plug in, natural log. Of course negative, but there is nothing negative here. Or, let's look at the graph of natural log, and you will see it in a minute.
0 and 0.
Exactly. So this has to be adjusted.
Greater than 0.
Exactly. Still, I haven't shown you anything else yet. I have still not proven that when I differentiate the natural log of the absolute value, I get 1 over x yet. Now I'm going to do that. So I'm going to differentiate this. So when I differentiate natural log of the absolute value of x, I get, when I differentiate this, what do I get? Perfect. For x greater than 0. When I differentiate this,
Negative.
1 over negative x times the inner function prime,
Plus.
negative 1. So 1 over negative x, 1 over negative x times negative 1. How much is that?
1 over X.
That's it. So now I can say, that indeed, when I differentiate log of the absolute value of x, I will always get 1 over x. And vice versa. When I integrate 1 over x, dx, I will always get natural log of the absolute value of x plus a constant c. Because these two happen to be the same. Okay. Any questions here before we look at other problems? Any questions? Questions? Okay, 35. I see it in red on the same page, 414. So everything here was on 414. So the integral from still indefinite. Cotangent x times cosecant squared x dx. So these both are function compositions, right? Cosecant squared, right? And this one is even uglier, the square root of cotangent. So let's think of a substitution.
Cotangent X.
Very good, and let's see if it works. Du must be in the problem. Plus or minus numbers, factors, in other words. So what do I get? Cotangent prime is,
Cosecant squared.
but negative, dx. Good. Not a problem to make up that negative. So I'm going to put a negative in front and a negative outside. In other words, I'm multiplying by negative 1 twice. When I multiply by negative 1 twice, is basically I multiply by 1. But now I have this piece. What does this equal to? Perfect. And what is this?
Square root U.
Very good. Or u to 1/2, because it's easier to handle that. So this is negative u to 1/2 plus 1 over 1/2 plus 1 plus a constant c. Maybe I should write the intermediate step. Allow me to write the intermediate step. So it's negative the integral from u to 1/2 du, which is this. So 1/2 plus 1 is 3/2. So I have to finish this as negative 2/3 u to 3/2 plus a constant c, or negative 2/3 u is cotangent x raised to 3/2 plus a constant c. Do you think we need more examples from indefinite integrals using the substitution rule? Or can we go to something else we will review again on Thursday? So our test is a week from today. So do you think I can review definite integrals using substitution rule? Or you think that we should do another problem with indefinite? Yes, Tom, go ahead.
This would be indefinite intervals, but I kind of struggle with intervals that have functions inside of them rather than a and b just being actual numbers.
So you're talking about the definite integrals or indefinite? This was indefinite.
Definite.
Okay, so we should go on to definite. Okay, very good. So let's do that.
I think it was one of the quiz problems.
Let's say 69. Let me know if we did 69. So e to the fourth? We did.
Yes. Yeah.
Okay. What about 73?
No.
The integral from 0 to 1 from dx over 1 plus the square root of x to the fourth power. Okay. Of course, in this case, there is pretty much only one option. I don't ever want to have sum of terms or difference of terms in the denominator. So I prefer one term in the denominator that I can handle. I can bring it up with a negative exponent. I can manipulate the way I like. But when it's a sum of terms or difference of terms, I really don't like it. So you will say, let u be,
1 plus 3/2.
let's give it a shot. We'll know immediately if we are on the right track or what we need to do and how. So remember, du must be in the problem or easy to manipulate or plus or minus numbers, factors. Okay, so let's see du. What do we get? Very good. Du. I'm sorry, dx, of course. du equals 1 over 2, the square root of x dx. Very good. Okay. So I do have a little bit of a problem, right? The 2, it's not a problem to make up. The square root of x, it's a function, but let's take a look at this. I have a way of getting that out of there. I could say from here the square root of x is
C. U plus 1 minus 1.
I can't go to a third variable. Okay, so now one option here would be Do not copy the limits of integration. Oh, let's copy the limits of integration now. So when x is 0, how much is u?
1.
When x is 1, how much is u?
2.
Perfect. Okay. So now the denominator is easy, right? Is 1 over u to the 4th. You do agree with that, correct? So 1 over this is 1 over u to the 4th. But now somehow I have to get rid of this. And I can. Multiplying here both sides by 2 to the square root of x. So 2 to the square root of x du equals dx. So I will be replacing this by 2 to the square root of x du. But I can have u and x in the same integral. So when I replace dx by 2 to the square root of x du, I will have to replace the square root of x by u minus 1. So I have 1 over this, which is here. 1 over this is 1 over u to the 4th. Now dx should be replaced by 2 to the square root of x du. Instead, I'm going to write 2 u minus 1 du. And you could say at this point, well, it looks like you made it more difficult. No, I'll show you why. Because now, because the denominator has only one term, I can do whatever I really, not whatever, but more or less. To the integral from 1 to 2, I distribute 1 over u to the 4th to u, and I get 1 over u to the 3rd minus 1 over u to the 4th. So I took 2 outside, and 1 over u to the 4th times u is 1 over u cubed, and 1 over u to the 4th times negative 1 is 1 over u to the 4th. Is this clear? Which part? Let's go back.
I'm still not clear on how exactly du was made to be in the problem.
Yes. So first, I noticed that I have 1 times dx over 1 plus the square root of x to the 4th. That's the same, right? So then this piece becomes 1 over u to the 4th,
Yeah.
right? So this is done. I already have it. It's here. Agreed? Okay. Now I have to get rid of dx. So from this equation, which is du equals 1 over 2 to the square root of x dx, multiply both sides by 2 to the square root of x.
Okay.
2 to the square root of x du equals dx.
Okay.
So I will have to replace dx by 2 to the square root of x du. But there is no way I can put here 2 to the square root of x du, because I cannot have u and x in the same problem.
So then you put it back to
So yes, so I subtracted 1 and I said, oh, the square root of x is the same with u minus 1, and that's how I replaced this piece by u minus 1. Because in this case I could not, and we can never have x and u in the same integral. These are not double integrals. You have to wait for that till Calc 3. Double integrals or triple integrals. So you will learn later on in Calc 3 something like the integral, whatever function, dx, dy, dz. But not in Calc 1. So for something like this, you have to wait till Calc 3. So I have to, once I change from the integral in x, in u, there is no more x. Okay, so far so good?
Yeah.
And then we distributed. I took 2 outside. 1 over u to the 4th times u is 1 over u to the 3rd. 1 over u to the 4th times negative 1 is this. Of course, I will make it even simpler with 2 in front. From 1 to 2, u to negative 3 minus u to negative 4 du, of course. So 2, u to negative 3 plus 1, negative 2 over negative 2, minus u to negative 4 plus 1, u to negative 3 over negative 3, from 1 to 2. Is this okay? So do I have to refresh your memory on the rule? The integral, yes? Okay. So the integral from x to the n dx is x to n plus 1 over n plus 1 plus a constant c. This is the rule we just used. So it was -3, -3 plus 1 over -3 plus 1. And when it's -4, -4 plus 1 over -4 plus 1. That's how we got -2, -2, -3, -3. Is that okay? Okay. So then I have, I will still like to simplify this a little bit, to negative 1 over 2u squared and plus 1 over 3u to the third from 1 to 2. Yes, I will plug in 2, and then I will subtract when I plug in 1. 2. I plug in 2. Negative 1 over 8 plus 1 over 24 minus, this one has minus, so plus 1/2 and minus 1/3. Okay, the least common denominator is 24. This needs a 3, this needs a 12, and this needs an 8. So -3 plus 1 plus 12 minus 8. So this is -11. I see the top, I think the top is 2. Times 2 is 4, 1/6. Am I correct? So -11, that's -10. So that's 2 times 2, 4. Is this okay? 1/6? Now, what I want to mention, and I didn't right here, is whenever we're asked to integrate, calculate a definite integral, like this one from 0 to 1, we have to make sure that the function inside is continuous. Is this function continuous between 0 and 1? So this function will not be continuous if x would not be greater than or equal to 0, which it is. And it will not be continuous if the square root of x plus 1 is 0. But the square root of x plus 1 can never be 0, because the square root of x is always positive, plus 1 is always positive. So yes, this function is continuous between 0 and 1. Therefore, we were able to, and allowed to, apply fundamental theorem of calculus part 2. Now, for example, on this problem, -1 to 4, from 1 over x dx, is this function continuous between -1 and 4? No, it's not continuous at what point?
0.
So I will say, wait until Calc 2. Fundamental theorem of calculus part 2 cannot be applied. Cannot be applied. Function is not continuous on the interval -1, 4. This is an improper integral. And we have to talk about the convergence. It's a different story. So please commit to memory. Every time we see a definite integral, what do we need to check first? The function is continuous, is defined at that, on that interval. So please remember that. Okay, so let's look at another problem. Let's look at 65. Did we do 65? The integral from 0 to a. X, the square root of x squared plus a squared dx, and we are told a is positive. Did we look at this problem? Okay, perfect. So although this is not the scientific way of thinking about it, but this is the basic idea. What I dislike about this function is what? A sum of two terms. I cannot have two variables. A is the upper limit. A sum of two terms under the square root. I completely dislike that. Why? Because I can never simplify it. So then, that's my thinking. I will say let u be
X squared.
and du yields 2x dx. I'm happy with that, bless you, because the only thing that is missing is a 2, so I can multiply by 2 and divide by 2 easily. That's never a problem. So therefore, the integral becomes 1/2. Do not copy the old limits of integration, please. So when x is 0, how much is u?
X squared.
Very good. When x is a, how much is u?
2x.
Very good, awesome. And now, please tell me what we have. The integral from a squared to 2a squared from what?
1/2.
The 1/2 is outside, yes.
So the 2 root u.
So all this is du. So this is the square root of u. So u to 1/2 du. Is that okay? Do we see this? So 2x dx is du, and the square root of u is u to 1/2. Okay so far? Okay. Now, no problem here, because I know this is our favorite friend now, u to 3/2 over 3/2, right? We had that so many times. So u to 3/2 over 3/2 from a squared to 2a squared. You have a problem like this, so that's why I wanted to show you a similar example. So I flip 2/3 and I get 1/3. So now I have 2a squared to 3/2 minus a squared to 3/2. So I plug in 2a squared, and I subtract when I plug in a squared. Oh, and Nick, I promised to give you paper. You need some? Oh, okay, I'm sorry. Okay, so then we have a 1/3 outside. So 2 to 3/2 is the square root of 2 cubed. So 2 to 3/2 is the square root of 8, which is 2 the square root of 2. A squared to 3/2 is a cubed. So 2 the square root of 2a cubed minus a cubed. And you can leave it as is. Or you can factor out a cubed, but it's fine. Okay. Any questions for me? The integral from negative pi over 3 to pi over 3 from x to the 4th sine x dx. Yes, please.
So it's acceptable for us to leave the coefficient outside and not distribute.
Yes, or if you would like, you can write it like a cubed over 3 to the square root of 2 minus 1. Either one. I'm fine. There is nothing you can really do here. Okay, so I see a definite integral. I see a function which is x to the 4th sine x. Is this function continuous between -5/3 and 5/3? Yes, of course. X to the fourth everywhere, sine x everywhere. No problem. What else I notice now? What is the next thing I see? I see that the interval is symmetric. Perfect. Good. So now I have to investigate for sure to see whether this function is odd or even. If it is odd, the answer would be perfect. If it is even, I reduce it to twice the integral from 0 to pi/3. Okay. So I have the function f of x, which is x to the fourth times sine x. How do I check whether it's odd or even? What do I need to determine?
Negative f of x.
No, f of negative x. But you're right. So if this equals f of x, I'll say even. If this equals negative f of x, I will say odd. What kind of function is x to the fourth? Odd or even? Remember its graph. Even. What type of function is sine?
Odd.
Indeed. So when I replace f by negative x, will I get f of x? Will I get negative f of x or none of the above? Correct. Since the function is odd and symmetric interval, what do I say? I have to write this. Odd function, symmetric interval. What do I conclude? Very good. Any questions? Any questions? Any questions? Okay, I'm going back now to a problem from 5.4 because we did not have an example like that. Okay. So let's say 59 on page 405. V of t equals 3t minus 5 on the interval 0 to 3. The velocity function in meters per second is given for a particle moving along a line. Find A, displacement. The displacement is a function. S of t, which is nothing else but the indefinite integral from v of t dt. And that is the integral from 3t minus 5 dt. And we know how to determine this. What do I write?
T squared.
Very good. This is the displacement. It's the distance function. In part B, we're asked to find the total distance traveled by the particle during the given time interval. We are given a time interval 0 to 3. So in part B, total distance. That is the definite integral from t1 to t2, which is 0 to 3 in our case, but from the absolute value of v of t dt. Can anyone explain why the absolute value? Why do I need to put the absolute value in there?
There's no negative time.
Because if it's going in the positive direction, positive velocity or negative velocity, doesn't matter, it still accumulates or covers distance. We did that a long time ago, if you remember, with a function in which we were asked, does the particle go in the positive direction, negative direction, and what is the total distance covered by the particle? Okay, So now the integral that we have to determine from 0 to 3, from 3t minus 5 in absolute value dt. Where's my next step? Because I can't find this before what? I can't. I will not ever be able to give you an antiderivative of a function that is absolute value. Okay, so then what are the options? 3t minus 5 for t greater than or equal to 5/3, right? For 3t minus 5 positive or 0. So I obtained this from writing 3t minus 5 greater than or equal to 0, and I got this. Moved 5 divided by 3. And what is the other possible option?
Negative 3t plus 1.
Very good. And I don't have to calculate what is not here must be here. Do not bother with determining anything. So if the first one is greater than or equal to 5/3, the second one must be less than 5/3. There is no other way. So therefore, our integral is what?
Improper.
No. The improper integral, let me tell you when proper integral, there are different types. When a function is undefined, in the interval blah blah. It's undefined, that's improper. And there are two other types. When one of the limits is infinity, either the bottom one or the top one. And the third type is when both are infinity. From negative infinity to infinity from f of x dx. That's one type. From negative infinity to 5, f of x dx, a different type. And when the function is undefined. 3 types of improper. Calc 2.
0 to 5.
I am very upset in my heart that I don't have a Calc 2 next semester. Sorry.
Would it be the integral from 0 to 5/3 plus the integral from 5/3 to 3?
Absolutely. Absolutely. So we have to break it up because the function is broken up. So below 5/3, I have negative 3t plus 5. And after 5/3, I have 3t minus 5. Totally different functions for different intervals. So that's why I have to break it up into 2 parts. And now from here on is a piece of cake. Cumbersome because of fractions and so on and so forth, but it's done. Negative 3t squared over 2 plus 5t, and this one goes from 0 to 5/3. And the same thing, but the signs are different, minus 5t, and this one goes from 5/3 to 3. And yes, I was really looking forward to continuing with Calc 2. And the techniques of integration by parts, and the trig substitutions and all that. And areas and surfaces and volumes. Okay. So I plug in 5/3. So it's negative 3/2 times 5/3 squared, which is 25 over 9, plus 5 multiplied by 5/3. I'm happy that when I plug in 0, I get 0, so I don't have to do it. Plus 3/2 times 9, minus 15, but minus 3/2 times 25/9, and plus 5 times 5/3. So let me caution you here, just in case. I copied negative 3/2 and I replaced 5/3. I copied 5 and I replaced 5/3. I should have written minus when I plug in 0, but that's 0. So now plus 3/2 times 9 and minus 15. But now I have to subtract when I plug in 5/3. So this must be negative and this must be positive. That's why I have negative 3/2 times 25 over 9, but plus 5 times 5/3. Okay, so let's see. I will simplify a 3. And I have negative 25 over 6 plus 25 over 3 plus 27 over 2 minus 15 minus 25 over 6 again plus 25 over 3. Very nice, nothing cancels. So this is 50, negative 50 over 6, and this is plus 50 over 3, plus 27 over 2 minus 15. Okay, the least common denominator is 6, negative 50, I need a 2, I need a 3, and I need a 6. Plus 100, plus, is this 81? And this one is this 90? Okay. So this will be 10. This will be 91. And minus 50 is 41. And if you say check that this was the distance, I'll say sorry. I can't. I'm just hoping that it's correct. I can go back and redo it. But the point I'm making is it's a definite integral. I don't have ways of checking. If it were an indefinite integral, yes. Yes, Bryce, did you find something? I'll be more than happy to go back.
50 over 50 thirds, you step down from there one.
Yes.
Is that 50?
25 over 3 plus 25 over 3. That's okay. I'll rather go back and check. It's very easy to make a error. So we know how to determine the total distance once we are given the velocity. We have to be given the interval, and we know how to determine the displacement if we are given, which is a function, if we are given the velocity. Okay, I did not have anything else left over from 5.4, so I'm going back now to see if I have anything left over from 5.3. And yes, we started it last time, but we didn't finish. So here we're going to look again at the functions given in the form of an integral. So let's take a look at number 14 on page 394. We're given a function h of x, which is the integral from 1 to the square root of x, and this is z squared over z to the 4th plus 1 dz. No one can ask us to evaluate something like this. This is a function given in the form of an integral. The only thing I can be asked to determine here is h prime. So we differentiate the left and we differentiate the right. And this is h prime of x. Remember what happens. If this is plane x, when I differentiate an integral and make sure that the lower limit is a constant, any constant you want, it doesn't matter, then all I get is z squared over z to the 4th plus 1. But I have to plug in that x. So since this is not plane x, I will still plug it in, but I will have to multiply by the inner function prime. So the square root of x squared will be x. The square root of x to the 4th will be x squared, and then plus 1 multiplied by the inner function prime. What is the inner function prime, which is the square root of x prime? That's it. That's all I can be asked to determine. Let's look at another, like 16. We're given another function. This time they call it y, but we know it's f of x, which is the integral from 0 to x to the 4th cosine square theta d theta. We're not asked to evaluate. This is a function. We're not evaluating. We're finding the derivative. So we're asked to find f prime of x. Two things I have to make sure. Is this a constant, the lower limit? Yes. And is that plain x? No, it's not plain x. So I have to multiply by the inner function, prime. So how do I write the answer then?
So it's x squared times
X to the 4th. So now theta becomes x to the 4th. Multiplied by,
4x to the 4th.
that's it. Yes, you can rearrange it by putting 4x to the 3rd in front. That's all we can be asked to find. Now here's the next question. If I ask you to determine the integral from 5 to 5 from any function f of x dx, what would you say? Absolutely. There is no width. It's just a vertical line. So there is no width. I want to find the area, the base, the width of the base is 0. So 0 times any function value, I don't care, it's still 0. Good. Now here's another question. The integral from 2 to 3 from f of x dx. It's the same with the integral with minus in front from 3 to 2 from f of x dx. So these are two properties of definite integrals. You find these properties on the checklist as well. So the integral from a to a from f of x dx is 0. The integral from a to b from f of x dx is the opposite of the integral from b to a from f of x dx. So now I would like to go back to other examples from the same thing, from this. Okay, so I'd like to look at 59, which is y, or f of x, the integral from cosine x to sine x from natural log, in parentheses, 1 plus 2v dv. And of course, what can we be asked here? One more time. We can only be asked to...
Find f prime.
Exactly. Very good. So we're asked to find f prime of x. Now I will say this. The right-hand side integral, which is the function in this case, is not set up. It does not have a constant at the lower limit. I cannot go ahead and differentiate both sides like I did here. This is not a constant. This is a constant, but this is not a constant here. So that's one problem. So I have to do something before I differentiate. Now, I want to refresh your memory on another property of the integrals, the definite integrals. The integral from 1 to 5 from f of x dx. Can I write it as the integral from, we already used this a few minutes ago, from 1 to 3 from f of x dx plus the integral from 3 to 5 from f of x dx? Can I write this? We just used it, right? With the total distance. We broke down the interval from 0 to 3 into 0 to 5/3 and from 5/3 to 3. Okay, perfect. So I'm going to apply this property here. I'm going to break this interval somewhere between this lower limit and the upper limit. And you can say, fine, that's wonderful. Where are you going to break it? I don't care. What? Okay, here it is. The integral from cosine x to any number you want, natural log of 1 plus 2v dv plus, and it must start at the same number, not that it matters at the end, to sine x natural log of 1 plus 2v dv. You can say I want 0 in there, put 0. You can say I want 1500 in there, put 1500. It doesn't matter. So now, which one is ready for differentiation and which one is not? The second one is, because I have a constant that's the lower limit. But what will I do with the first one to make exactly? Thank you. So then this equals negative the integral from whatever you want to cosine x natural log of 1 plus 2v dv and plus the integral from whatever number you want to sine x from natural log 1 plus 2v dv. Exactly. And now we are ready to find f prime. And tell me what you would write for f prime. Negative natural log parentheses. Oh, I have something in here. I think I'm using, you know what I'm using? I'm using your scratch paper from some test. It had some scratchy in there. Okay, natural log 1 plus very good times
times 2 sine it, right, negative.
perfect plus times, that's it. All I will do is just rearrange. I have two negatives in the product, so I will put sine in front, cosine in front, and nothing. I can't do anything else. So sine x times natural log 1 plus 2 cosine x and plus cosine x natural log and 1 plus 2 sine x. Do we want another? Perfect. Okay. So let's look at 57 on 395. F of x equals the integral from x to x squared from e raised to t squared dt.